Okay, so we're continuing on with surface area of pyramids and cones. This number 3 here is a right cone. So in order to draw that, all you gotta do is draw what looks like to be the beginning of a triangle, and then you just need to sketch in an oval. Okay, so sketch in an oval at the bottom, and you'll end up sketching a cone. Okay. Okay, so let's read the question. It says a right cone has a radius of 4. Let's sketch that in. Does it go the whole way across or just halfway? Good, so this is 4 meters. And it says it has a height of 10. So do I put the height of 10 from the apex down, or do I use the slant? Which one is it? Apex down, yeah, because it just said height. If it says slant height, then you would put it on the slant. Okay, so it says calculate the surface area of this cone to the nearest square meter. And they give you the formula. Of course, the formula is on your formula sheet as well. So it says pi rs plus pi r square. Do you guys remember what the pi r square represents? The pi r square. Not circumference, no. No, not diameter. What is pi r square? Area of one circle. So that would be the base. That's the area of the base. Okay. And then this pi rs is like the lateral area. Very good. Way to use the proper terminology. Okay. Now, in your homework, they were very specific about, okay, now you need to solve for the lateral area. Now you need to do all the area. Okay. And on tests, they will always ask for lateral area. So make sure you know it. This question is not asking for it. But we need to make a mention of what this S is. What's this S right there? That is the slant. Okay, this is right here. S is on the slant. It's the length of the slant. So in order to find the length of that slant, what do you see in here? Very good, a right triangle. So on the side, you can quickly do a Pythagorean shortcut. Is it a long side or a short side? Long side. So we will end up adding. What are the two values? 10 and 4. And if we square those, add them, and square root, you will get a value for a slant height. Can someone do that for me quick? Who's got it? How did I beat you? 10.77? And I'm just going to take a couple more decimals for accuracy. Now I can go to my formula. And like if you did your homework, you realize that use the pi button. Then in your calculator, you can just put like pi and then put a bracket. The radius is 4 and then a bracket. And I'll put my 10.7703 there. Use the pi button, and then the radius is 4, and then you use the power button to get the 2 up there. And then you could literally type that in. If you have a nice calculator, you can type it in exactly how you see it, like that. And if you're looking for the pi button on the graphing calculator, it's second, the little house, the little exponent thing. And I have arrived at 185.6. And it wants me to round to the nearest square meter. So rounding, little squiggle, 186 square meters. This little squiggle, I'll do that from time to time. That just means I've rounded this little squiggle. All right, number 4 looks a bit challenging. I just can tell by looking at it. It says that the lateral surface area of a square pyramid is 3,000 square inches. Okay, so I'm going to highlight that. And what that tells me, and I'm going to make a little note of that, is that the area is given. Therefore, algebra is required. And this is always on the test and the final, where they give you the area and you have to figure out one of the components. So if you look at the screen and you see like this formula up here, it's for the cone, but say they gave us the surface area of the cone. I would have to change, see this thing here, SA? I would have to change that to the area they gave me, and then I would have to solve for one of these, whether it's R or S or whatever. Okay, so what we need to do in number 4 is the lateral surface area of a pyramid. So what is the formula for a lateral surface area of a pyramid? Well, I need to think. I can't just look at my yellow sheet. So what does lateral mean? The sides. So in other words, no base. Okay? So how many sides are there? 4 sides. And what are their shape? Triangle. And are they all the same? That's if it's a rectangle base. It looks like a rectangle in the picture, 100% you're correct, but it's in fact a square. So all those triangles are the same. If it's a rectangle, like you thought it was, because the picture's deceiving, then yeah, then you'd have 2 separate triangles. But this one's kind of nice. So what's the surface area formula for the lateral pyramid here? 4 triangles. So 4 times, well, what's the area of a triangle? BH over 2. So it's just 4 triangles, 4 times the area of one triangle. I'm going to do a quick cancellation. What's 4 divided by 2? 2. So surface area equals 2BH. People okay with that 4 divided by 2? 4 in the top, 2 in the bottom, just cancels for 2. Now I can input the things that I know. What is the 3,000? So that goes here. The 2 is 2. What do I put for B? The base is 50. So I don't know H. Look what it says. Determine H. All right, now we're almost done. 3,000. What's 2 times 50? 100. H. So it's 100 times something gives me 3,000. How do I solve a problem like this? Divide out the coefficient. So it's 3,000 divided by 100 equals H. This one's easy. Looks like 30 divided by 1. And what's the unit for the height? Inch. Okay. Because we solved for a one-dimensional unit, it's just inch. Okay. Notice that the surface area unit they gave us was inch squared. Okay, so you wouldn't put inch squared down here. You just put inch because height is one-dimensional. Okay, so at the bottom of this page, you can see the homework that was supposed to be accomplished. Okay, so I'm going to give you guys roughly 5 minutes to look at this homework, and then I'm going to give you the next quiz. Okay, so we have volume of pyramids and volume of cone. If you look on your yellow sheet, we can jot these in. For the cone, now you're looking on the very right side, you have 1/3 pi r squared h. Okay, so let's take a look at this formula. The 1/3 in the calculator, you can enter that like this. 1 divide 3 in a bracket. That's how you can put it in the calculator. Okay? And then you'll have pi, that's the pi button obviously. And then your radius, that one's easy, we've seen this before. And you're going to times it by h. So nothing crazy here. What I want to show you though is that this, what is pi r squared? That's an area of a, yeah, it's the area of the base. And then you times it by the height. Okay? And this is a very common volume formula. Just the area of the base times the height. And the reason we divide it by 3 is because just like a cone and a pyramid, you could fit 3 into the cylinder. Because what's the formula for a cylinder? Pi r squared h. It's right above you on your formula sheet. So it's the exact same formula for the cylinder, except for the cone, you basically just divide by 3. That's what this 1/3 is at the front. It's 1/3 of the normal cylinder would be. Okay? And remember what volume is. Volume is 3-dimensional space. Okay? The next one is right prism. This is just a box. Okay? It is LWH. Nothing crazy about that. It's at the top of your formula sheet. Okay, and now if you look at the formula for a pyramid, it's 1/3 LWH. And I usually write my L's like this, so you don't get them confused with a 1. Okay, and again, I'll show you this relationship. What is LW? Length times width. That's the area of a rectangular base. And then you just times it by the height. Okay? So area of a base times height. And if you want to take a picture of that, or draw a picture of that, let's draw in a rectangular base. Imagine this is 2-dimensional. It's a 2-dimensional rectangle. Okay? That's this area of the base. Now, if you times it by a height, that means you're going to raise it out of the page like this, and then you've now entered 3-dimensional space. Okay? This height will now let you accomplish volume, the space inside. It's like, imagine you had a dime. Imagine the dime is 2-dimensional, it's just flat. What if you just kept stacking dimes? It's the area of the base times the height. And now you're entering 3-dimensional space. Okay, so area of the base times the height. And for the pyramid and the cone, there's this extra 1/3 at the front. You just divide by 3 at the beginning. Okay, and volume is always typically easier than surface area. Volume, you see a volume question on your test, you take a sigh of relief because it's way easier. You don't have to break things down into components. You don't have to think about if it's a rectangle base or a square base, what's going to happen to the triangles. I don't have to add things separately. Okay. Now let's take a look. First one looks very easy. It's a box, LWH, length times width times height, 6, 8, 5. Okay, 8 times 5 is 40. 6 times 4 is 24, so this is 240. And the unit is centimeter cube. So this is the difference now in volume. The unit changes now to 3 dimensions. Now we can jump into cylinder. The volume of a cylinder, pi r squared times h. So that's the area of a circle, pi r squared, times h, which is 5. So pi, what's the radius here? If they give you a diameter of 2, halfway would be 1. So this is pi times 1 squared times h, which is 5. Now 1 squared is just 1. So this is 1 pi times 5. What's 1 times 5? 5. So this is just 5 pi, whatever 5 pi is. Okay. Someone got 5 pi for me? 15.7? Sure. And the unit would be meter cube. Good. Okay, good. Flipping the page. Calculate the total volume of the pipe shown at the right. The pipe is 0.5 centimeters thick. Round your answer to the nearest tenth of a centimeter. Okay, so this is like, imagine a toilet paper roll. You know how the toilet paper roll has like a hole in the middle? Okay, if the toilet paper didn't have a hole in the middle, it would just be a thick cylinder that you could find the space inside. But if you hollow out the middle, you have to subtract another cylinder. Does that make sense? It's like take a cylinder out. Okay? So what you need here for the formula for volume total, that's what they're asking for. Okay, it's the volume of the outside take away the volume of the inside. Because it's like you're hollowing out a cylinder with another cylinder. Okay? So the formula for cylinder is pi r squared h. Okay? Pi r squared h. And the other one is also pi r squared h, but the r's are different. You have the r of the outside and you have the r of the inside. Okay? So what are these radiuses, or radii? What are these radii? You would need, like, the volume of the outside is just like if there was no hole. So you would just use this normal radius, like from the far edge to the outside. And if it's 11 the whole way, halfway would be 5.5. So there's our first radius, 5.5 squared. And h is 15 for both. So 15 for both. Now all we have to do is think about what the other radius will be. So I'm just going to switch colors and we can think about what this radius of the inside is going to be. This is what we're hollowing out. So that's like from there to there. So it's like 5.5 with a little bit taken off. How much is taken off? The pipe is 0.5. So take off 0.5 and you arrive at just 5. Okay? So you go and input this into your calculator. And in fact, you could type all this into your calculator, all in one line. You didn't, and it would do it perfectly. Okay, and I'm just going to do that now. And I've got 247.4 centimeter cube. So this is just volume with a little twist, a little problem-solving twist, okay, where you have to subtract something out. Okay, the next question is a famous Toblerone bar. It is in the shape of like a tent. What do they call this shape? It's a prism, and the base is a triangle, so triangular prism. Is triangular prism on your formula sheet? No. Okay, so in general, for all prisms, I'm going to write this down. For all prisms, volume equals area of the base times the height. Okay, so if it was a rectangular prism, it'd be LWH. If it's a triangular prism, what's the area of a triangle? Base times height over 2 times h. What the heck? Is that the same h? It's not the same h. They're different h's. We have to be very careful with our letters. So I'm going to actually change one of these. Okay, I'm just going to change one of them to capital H. Just for this example. I'm going to call it capital H. So that's here. That's this. This is capital H. What's this 26 over here? No, that's the height of the prism. If you were to stand it up on its edge, that would be the height of the prism. So that's this little h over here in the formula. So we have a big H, we have a little h. People okay with that? Yep, 26 is the little h. It's the height of the prism. And capital H is the height of the triangle's face. Because remember, what we need to do is we need to find this area of this triangle. And then we'll times it by the height. Okay? So what do they give us for information here? It's an equilateral triangle with a side measure of 4.2. So how are we going to solve for this capital H? What do you think? Probably some Pythagoras? Probably. All right. So this is capital H. This is 4.2 because it's equilateral. All the side lengths are the same. And what's this bottom one? Is it all of 4.2 or is it halfway? It's halfway. So 2.1? Okay, so now we need to solve for capital H using Pythagorean theorem. So use the shortcut. It's a long side or short side? Short side. So we'll subtract big number first. Okay, so I got 3.637. So I've solved for capital H. Now I can use that in my volume formula. So base times height divided by 2, that'll be 4.2 times 3.637 all over 2 times the height of the prism, which is 26. I have 198.596. Round your answer to the nearest hundredth. So from the calculator, I got 198.5969. So rounding nearest hundredth looks like 60 and centimeter cube. Let's see if we can beat the announcements. Okay, so this next question, if you look ahead, it says it has a height of 8 and a volume of 300 meters cube. Do you remember in the last notes where they gave us the area and we had to do some algebra? So this is the exact same style. So this case, you can write this in, volume given. So I'm going to need algebra. Some kids try to like guess and check. If it's a multiple choice question, it'll work. You can guess and check. If it's numeric response, you absolutely cannot guess and check because you're going to be off by at least a few decimals. You might get close though, you never know. But you should be practicing your algebra. So draw in your cone. Now we got some cool music to do this math to. We have a height.
Good morning, East Glen.
A height of 8.
An announcement for Tuesday, February 9th.
And it says, determine the radius.
There will be a mandatory eat tomorrow in Miss Ferguson's room. That's room 120. No, actually, that's today.
So I'll tell you this. For volume,
Mandatory eat meeting this Wednesday, February 9th. It
never
doesn't work.
use
We don't know anymore.
slant
Meeting tomorrow. Go there.
height.
Or today.
Okay?
We have no idea.
So in this example, we're good. They gave us the proper height. This H is 8 is good.
Yes, room 120. Our next East Glen blood drive for the year will be held
Okay, the
Thursday,
slant
February
heights
18th from 3 p.m. to
are
5
for
p.m.
surface area only.
At the U of A clinic. The blood drive will build up our yearly tally for the Young Blood for Life drive.
So for this question,
Save a life.
all you have to do,
17 years or older, or staff member,
jot down the volume formula
sign up and get further details.
of a cone.
They'll be first come, first served, since there are only 14 appointment slots available on Thursday, February 18th. Blood.
Input what you know.
To give. Exactly. Wisest. Women in scholarship, engineering, and technology.
So do we know the value of V?
You know that thing we were talking about yesterday?
What is it?
Well, we're saying it again.
300.
The Wisest Summer Research Program is unlike any other summer job.
Pi is pi.
Possibly imagine.
We don't know R. Do we know H? Yes.
Under the guide
H is
mandatory,
8.
mentorship of University of Belgrade.
I'm going to highlight
Graduate students. program
the
is
constants.
designed to give students the skills and knowledge they need to succeed in university.
This is our coefficient.
And technology fields. Or STEM fields. Who is this for? Grade 11 students by application only.
Okay, so solve the coefficient.
August 16th, 2016. Where? The U of A.
So what's 1/3 pi? 1 divide 3 in a bracket
4 p.m. Please see Ms.
times
Ferguson,
pi
20 for further details.
times 8.
Don't look like all of these are Ms. Ferguson. Go see Ms. Ferguson for all the announcements, apparently.
Looks like I have
Except for this next one.
8.3
Tomorrow will be the last
7,
day of
7,
for February. If you
5
still need one, please
R
come by
square.
office in the morning, at lunch, or after school with your ID. Reminder to executive leadership group to meet in the conference room during East today. And it's lunchtime. Come out and have some soup and bannock and meet our First Nations Métis and Inuit liaison, Miss Jake Brown.
Divide out that coefficient.
All staff and students are welcome. And now for today's birthdays, happy birthdays to Nessa Cogswell, Fred Watson DeRoche, and Nate Zoe. Happy birthday, everybody.
30 more seconds, guys. Divide out the coefficient, you get 35.8.
Special announcement for East Glen's improv team.
And now to solve this, you square root.
Citadel Theater for the CIG, which is the Canadian Improv Games. Winner of this gets to go on all expenses paid trip to Ottawa in order for competition.
So 5.98
International
to the nearest meter, 6
So,
meters.
congratulations to as follows: Austin Moan, Lily Kenton,